So let's begin our first program in C++ and try to explain these 1, 2, 3, 4, and 5 lines of code. And I will write my code in Visual Studio Code and I have already created a workspace on the desktop, and my workspace is a folder inside a directory 211, and this is the folder that I'm gonna create files for C++. All right, so let's go to Visual Studio, and I'm gonna create a new file, and this is going to be our first C++ program, right? And let's say my first program.cpp. CPP stands for the C++, right? And another thing, there should not be any space between this name, that you must need to remember this one, and otherwise there will be a compilation error during when we run and build this task to an exe file. All right, so I have just created a new file, and in this file let's include our header section that include input, output, IO stream, and you see now compiler is giving some pop-ups to autofill these libraries, because we're writing a C++ code, and Visual Studio Code is providing this flexibility to us to autofill these. Include input and output stream, and then we need a namespace using name namespace std, and this is our entry point of C++ program, int main, and opening block and closing block. So you will write your C++ code here. I will put comments here that the entry point of your C++ program, right? And this this area is your header section. I will just put some comments there, and these comments will be ignored by the compiler, all right? And header section, sometimes I call them preprocessor, and the header section closed at this point. Header section ends here. All right, and let's try to run our first program. That will be to print cout character out double quotes is a string hello world. All right, and this is now a complete statement. If I miss this double quote, is not a complete statement. Now we have a syntax error, because strings always enclosed in double quotes. If I miss the semicolon, then there will be again a syntax error, and it's not a complete statement. Now it's a complete statement. If I miss even this angle bracket, then there again will be a syntax error, and we need to follow the syntax of C++ programming. So now let's try to run this one. So I would recommend to use a command based running of this program. To I will open a terminal and open a new terminal. So I will have two terminals at this point right now. Open one is here and another one is here. And I'm going to use, so this is my Windows operating system. So the compiler will be G++. All right. So G++, and the name of your file, my file name is my first, and then I press tab, it will autofill the whole name with .cpp and -o. I like to rename the exe file, because now we wrote the program in high programming language, and we will convert into a 01 format binary code so that computer can understand, and that will be -o, and could be any name that you want this file in an exe format. So let's say same name, I'm gonna create the same name, my first program, and there's no need to put .exe here. If I press enter, you will see on the left side there will be a new file here, will with an extension .exe. Let's run this command, and you will see new file will be here. You see this one. So this is an exe file that we need to run. So now dot slash, and the name of the file is mass program, my first program. Again I press tab and fill the whole name, and I do not need to run now cpp, because cpp is a high level programming language code. I need to run dot exe here, and you will see the output exe. Here we go. Here we have hello world. All right. So now if we look at this program, we have two two statements. One is hello world, and then we use a method endl that will just break the line and it will move the cursor to the next line. Then we have another statement cout how are you, and we again use endl, it will move the cursor to the next line. And these are the commands. Okay, this is another command, this is another commands. And space, and also we have some spaces here, you can see some spaces here, and we have some spaces like here we put some spaces and we put comments. So spaces that appear outside the quotation marks generally do not affect the behavior of the program. All right. So you can put spaces anywhere in your C++ program. Let's say I like to put some spaces here, maybe here, here, no problem. Okay. So it will not change the behavior of your C++ program. Okay. I'm going to run same, compile it, and then run the exe, and you see the same hello world output is still there. All right. Then what will be the output for this program? The output will be same because we have two statement. If we look at clearly that we have two statement, then one is the cout with double quotes goodbye comma, and this comma is inside this double quotes. That means it's a part of character, it's a combination of characters. And then we have a semicolon here, that means it's a complete statement. And after cout at the end we have another statement here, and then endl. Okay, that's been two statements. So you will see goodbye and wonderful world. So there's no error. The only thing I like to mention here is that we remove spaces, but we following the syntax exactly the same way. If I go to Visual Studio Code here and make my program like that way, I remove these all spaces, move this up, and I also remove this space and move this curly bracket to line 7, and also remove these spaces. I don't need it. Let's say if I don't need these spaces. Okay, and let's try to run this again. Uh, and run and build, and then I gonna run it with an exe, and you see there is the same output. Okay, so this space is just to make your program easy to understandable for programmers in the future. If they open, let's say you have 1,000 lines of code and they have uh like they look like this way, then it would be a very problematic for you to understand your code. So try to make your code readable. Okay, so this is we have just discussed that these are called preprocessed directives, and these preprocessed directives will be in the header section of your C++ program, and that we have included in our first program, that is input and output stream. And and C in and C out is defined in this in include input and output stream. So that is saying both C and C are declared in the header file input and output stream, but within the name std namespace. Okay, to use C and C or in our use the following. So you need to use like that way. You need to include this library. It's a preprocessed library, and we call this in header section, and also using namespace std. And and for the statements, if we look at this program, we have only two statements here, one and two. Okay, but you can have n number of statements. So the syntax over your C++ program or the main area starts from this curly bracket and end at this curly bracket. You can have statement from 1 to statement n number of statements you can put inside your main method. So it's a main method or main function. All right. And what do you think will be the output of this one? So, and the output of this program will be just one curly bracket. Why? Because we now have one single quote. One single quote means that it's not a string, it's a just a character here. Okay. And we only have a closing curly bracket. So we string is a combination of characters, and then character is again another data type, right? And that is used just for alphabets and symbols. All right. And after that, we discuss uh, values. A values is one of the fundamental things like letters or numbers. right? In almost all programming languages, we have values. We have variables, they hold values, right? And if we talk about some data types like 1 and 17, let's say my my height is 5.9, and 5.9 is a float value, right? And my weight, let's say 65 kg kilogram, and then that will be integer value, right? Because it doesn't have any decimal points. All right. So for so we discuss one data type, that is integer, and integer will be whole numbers, 1 or 17s, and the character data types will be within close with single quotes, and it will be just one character. All right. All right, so we have other data types like we have character, short, int, long, bool, unsigned character, unsigned short, unsigned int, and unsigned long, and then we have floating point like float and double, and we use them based on scenarios, right? So for the bool we have true or false. It will be 0 or 1. Long we use if we have a number, a very huge number that cannot be handled by the integer data type, then we use long, that because take more memory, 64 bytes. And if you look at some memory, they take like integer take 4 bytes, and bool take 1 byte, and character take 1 byte. 1 byte means 8 bits is equal to 1 byte, and long you can save up to these numbers, and they can 64 bytes in the memory. All right. And I think, and I believe there is a method. That method is called size of. Let me show you the size of cout, and I'm going to use size of method, and I'm going to put that I need to know the size of integer. And let's run this program, and let's put endl here so that you can see clearly. And then to move the cursor next line, and if I run the same program, and okay, hello world and size of int, so it's not showing out for. Oh, I need to save it. I think I missed to save it, because have you seen there was a white curly white circle was there? That means I haven't saved it. So let's do again. And yes, you see now int takes 4 bytes. See, it takes 4 bytes. So that's mean if I use what is the size of cout, size of bool, and let's again break the line, and then also again break the line from here, and put just copy this one and paste here, and see the size of chr. All right, and now you see this white circle. I'm gonna press now Control S, and then again I use the commands to run this program, and I need to run the exe, and you see, so size of int is 4, and size of bool is 1 byte, and size of character is 1 byte. That's mean 1 bytes mean the, let me put some comments here. 1 bytes mean 0 0 0 0 0 4 5 6 7 8. These are 8 bits. 8 bits is equal to 1 byte. Make sense? All right. So next we, these are examples of saving integer values. And what else we have? So bool is value will be true or false, and float. So this is an important, the difference between float and double. So let's first look at the memory they take. So the float take floy float, and I also paste double here, and I put some strings so to make a difference, that is double, and this one is this one is this one is float. All right, And let's again run this program. And oh, I think I okay. So float take 4 bytes and double take 8 bytes. 8 bytes mean the 64 bits, and 4 bytes mean 32 bits. All right. Now there is more difference that I like to discuss between float and double. So let's say we have these values, and the one value is float. Both can save decimal points, but the difference is, let's try to understand the difference here. So we have uh, a float value that is 3.141592653589793, and then I put f, and then this is a float value, and this is a double value, and both numbers are same. Both numbers are sums. So I included another preprocessor in a file required to format for floating point numbers. This is called IOMANIP. This is a library that is used to set precision. So first I set a 6 decimal precision, okay, and then I set 15 decimal precision just to see in an output of these two values, because both numbers are same. I like to see the difference between what actually the difference between float and double. All right, so I let me just copy the same code from here and put in my first program where I'm working. And let's also separate this with just a separation. The separation is, I'm going to put one separation like this way, so I can see the difference between float and double. All right, so I just put my code here. We have float value, we have double values, and we set precision. So you see now the red line below is saying that you need to include a library. That library, I'm missing that library. We need to include the header section. I just copied from my this code and paste it here. All right, so you will not see this red line. So red line gone. That's mean we can now set precision. Okay, let's try to run the same program again and see the difference now between float and double. Now we need to focus on float and double, not the values above. Let me actually comment this one. We don't need to show this one. So the short command to comment all these one is this control backslash. Okay, control backslash. I selected all these, control backslash did turn on, and control backslash to comment. All right. So now I like to see the difference actually. So you will get also an idea. All right. So let's run this program again. And oh, I have to save it first. And now let's run this again. And oh no, again. And now let's run this program and see the difference. Okay. So we have these numbers, and it's saying, so this is the separation that we put this, so the output start from here. This is the character output stream. So this is the first 6 decimal places for the float and 6 decimal places for the double. Okay, so 3.141593, 3.141593. See, that means both can show correct value up to 6 decimal precision, 6 decimal. Okay, and if I look at to 15 decimal positions, that means we have 3.1492792. You see, so that's mean float can save value up to 6 decimal precisions, correct values, and after that these 74101257, these are not actual value we have here that we actually assign initially. And if we look at double, and it has exactly the same value we have here, this one. So that's mean float can save up to 6 decimal precision, and double can save up to 15 decimal precision. That's the difference between float and double. Okay, so based on scenarios we can use, if you need six decimal precision after decimal point, then use float, or otherwise use double. And also consider this in mind that the float takes 4 bytes and double takes 8 bytes. That's mean let's turn on these two. And let's run this program. Oh, let me save this program first and run again. This program and my program.xc. And yes, float take 4 and double take 8 bytes. That's another difference. Alright, so you got the difference between float and double, and now so this is what maximum number of significant digits. Decimal places for float values are 6 and 7 maximum that we have just seen, and the maximum number of significant digits for double 15. So the difference is also there.